So what's Calc 1 going to deal with? Calc 1 basically is differentiation. Differentiation is the name we give to a process in mathematics where we find the slope of a tangent line to a curve at a given point. Doesn't seem that inspiring that finding the slope of a tangent line to a curve at any given point is that much of a biggie. But actually, it's hugely important because it's the beginning of calculus. And that problem, or that came about from a problem that's called the tangent line problem. And I will get into that later today. But before we do that, let's look at our syllabus and all that stuff that you kind of have to go through because my boss tells me I have to. So, and it's useful. So if you could bear with me for a few moments, I'm now going to do the dangerous thing of changing screens, which can certainly be hilarious at times. So here goes. And what screen am I going to show you? And will it work? Let's try that one. Are you looking at our Canvas site, Math 151?
Yep.
Yay, great. Okay, so you all know that yeah, every class has a Canvas site. This is ours. And in this site, there is tons and tons of stuff. Just shrink this back a little bit. This is my version. If I went and hit up here, you'd get the student version, but they're not that different, right? I just don't want to jump between student and mine because sometimes if I do a student version of what you see, it won't let me show you certain things because I'm actually not really a student. Okay, so hopefully you've clicked on welcome and it'll tell you a little bit about me. And then one of the most important things you're going to do in the next couple of days is you need to enroll in WebAssign. WebAssign is how we, is really the essence of where your homework assignments are. It's where your ebook is, and it has lots of other goodies that you can use. You've got instructions there. Basically, we have a special key that is only for this class, and you use that key to get into our WebAssign class. It's very specific to us. And here is WebAssign. The fact that you got here, or at least the ones who are here, know how to do Zoom now. These two guys here will be more important when we get to our first test. But essentially what's going to happen is that we have a test basically every second Monday. It's called test 1, 2, 3, 4, and 5. And it covers 2 weeks work. And it's worth 20% of your grade altogether. And you will do your test in WebAssign. Right, the questions will be in WebAssign, just like homework. The difference is that I need to see you're working. And what you do is you basically get your camera, you know, your photograph from your phone camera. You hit pictures, you use this software, it turns into a PDF and you upload it into Canvas. This doesn't really matter right now, but when we get closer to the time, I will take you through it so you don't need to freak out. Now, let's close this one off a little bit. This guy here is our day-to-day stuff. If you want to talk to me, there's my officer at 10 o'clock. There will be a Zoom lesson. I don't know if you call it a Zoom lesson, a Zoom meeting. There it is. You just click on it. It's just like knocking on my door. I'll open it up and you'll get in. And that will be it. So that's where our office are. Now, it might not work for you because you've got an English 101 or something at 10. Then what you do to me is you shoot me an email to my official email address, nothing else. So don't leave messages in WebAssign. I know it has a feature where talk to my teacher or ask for extension or who knows what else. I don't know what else it does. Whatever it does, it goes into the ether and I never see it. So you'll be talking to the ether. Yes, Robin?
Does Canvas work as well, or is it only through email?
Canvas is perfect because Canvas is my email address. That's what it uses. So you can use Canvas perfectly fine, or just D Robertson, Olympic.edu. Here the second one. This is our day-to-day kind of stuff. Here is the link that you used that I sent an email to. This link will be used until May the 21st. That's evidently that's as far ahead as Zoom will allow me to do it. Okay, so that will be the Zoom thing. I'll try and remember, but sometimes I get busy and I forget. This is the link that you'll use tomorrow. This is the link you'll use 3 weeks and Tuesday and whatever else. Now here, this is empty right now, but every meeting, including this one, will get recorded. So if I say something and you say, God, he showed us someone a calculator, but I forgot what it was, you can come back here and look at the entire, well, skip to the bit you want and look at it. Essentially, you just click on that and our first one will be there, and Tuesdays will be there, and Wednesday will be there. You don't want to miss any days because you get participation grades. But if you do, because you know, life is life, things get happen. I strongly suggest that you go to these and you watch it, you know, as a replacement. Any questions so far? Pretty good. Okay, let's move on. And this thing here is another resource. What I've done is I've went to YouTube and wherever else I could find it, and I got other people's videos and I've linked them here. So that you might want to see someone else's way of describing it, or just extra questions that are done for you or whatever. It's just a resource. You can choose to look at them or not, but it's there for you. And here's Desmos. Desmos is kind of helpful. You can, they shouldn't be capitals, but that's fine. It's pretty, I like it myself personally, I like it anyway, because it's colorful and it's big. And you can move things around quite well. Now, your TI-84 calculator is going to get used, but it's not as pretty, right? It's not as visual, and it's a lot easier, right? So it's just a resource. So if you wonder what it's for, it is a resource. Oops, I don't want to, do I want to do that? Yes, I do. There we go. Here is something where the college has provided this, and it's basically help on everything and anything you could possibly think of, and probably some more. So that's that one. This one you don't have access to, but this is where I dump stuff. You know, once we've finished chapter 2, I'll probably dump it in here so it's not cluttering up your 151 resources. Right, now you want to talk to me? Someone mentioned it, I think it was Robin. If you click on inbox, well, this is my version of inbox, yours is probably similar. You can hit that little guy and write a letter, write an email. Or you can do it through Access. So that is essentially what Canvas looks like. I'm going to be leaving this shortly. Any questions? Right. And I just realized I'm not going to be leaving Canvas shortly because there's something I forgot to show you. And it's probably important. These are all my classes, and there's yours. I forgot to show you the syllabus. Right. So here is the syllabus. You better have prerequisites. I'm assuming that you do. Here are important dates. Here's the times and the dates of our tests. Here is your final. On Monday the 26th, I will not be here. The rest of the college will be, so don't say Mr. Robertson said I could have Monday off to your English professor, because that's not true. That's my personal day. I'm taking it off for personal reasons. But I won't be here, so the class won't happen. If you're interested in seeing the work that's going to be covered, it gets covered in 2-week chunks, most of it. The first 2 weeks are getting started with WebAssign, which is an assignment in WebAssign, and these 4 sections. And then the homework is due in 2-week chunks. So midnight of Sunday the 18th, this has to be done. If it ain't finished, you'll get graded on what you've done. Question? No? Okay. And then you do this chunk, then you do this chunk. You got the gist of it, right? You do this chunk, you do this chunk. There's your last test. There are 5 tests, but the best 4 counts. So on Monday, the 14th of June, which is officially the last class teaching day, test 5 happens. And all the tests have the same format. You turn up to a Zoom lesson so I can make sure you're not cheating and asking your big brother. And you do it on WebAssign, and then you do your working. Well, actually, you'll do your working as you're doing the test, and you'll use that Adobe thing I told you to upload it into Canvas so I can see your working. And then the final exam is like a very big version of what you do for the test, with one major exception. It's not on WebAssign. The final exam is a PDF that will be in Canvas, and it will appear at 7 o'clock in the morning. So now I'm happy. There's a whole load of other stuff here that you can read, but it's up to you. I think you all know how to read, so I'll let you figure it out. Basically tells you, well, I guess I should do that one. It tells you what everything is worth. So coming to class is 10% of your grade. Sometime during this class, I'll ask you all to say hi. Seems a silly thing to say, but hi as in type it in. And then what I do is I suck that out and I use that to take attendance. So it's a good idea that you have your name and don't call yourself Funny Rabbit 42, because I don't know who Funny Rabbit 42 is. And so in particular, will you make sure that you have your name. And if you haven't figured that out, because this is the first day and you didn't know, when you say hi, will you say, hi, I'm John Smith? So I know that's who you are. But I don't want to have to do that with everybody. That would take forever. So 10% of your grade. Basically, every attendance is 2 points. And since there's 50 days of attendance, there's your 100 points. Figure out 10% of that. Homework's 20% of your grade. The tests are 30 and your final is 40. And now I'm going to skip by the rest. Are we good? Right. So let me just close that off. I've got enough things opened up already. And I'll close this down and stop the share. And now the next thing I'm going to show you is WebAssign. TRYG. Whoever TRYG is.
Yeah, my camera doesn't work. I have to like close my app again. So.
Okay, I'll let you figure that out. While we're doing that, I'm going to have to jump to.
You probably have to let me in again.
Not a problem. I can do that. Right, so we'll click on Cengage. Oh God, I need a new set of eyes. Hold on a second. I'll try and figure out where my next page is. Here we go. You should be looking at Cengage now, right? Okay, so you're looking at this fella. Oh, I do have it in Students View. So what you can see here are 2 weeks worth of homework assignments. Now, if you've never used WebAssign before, it's a, well, let's show you some. If I click on this, hopefully it'll work. I'm in Student View. There we go. Each homework assignment is worth 100. Here is the question. You click on that, you type in your answers. I'm making this up. 42, 60, 20, 10, No, 9 of 9. And 42 again. And you submit your answer. And they're all wrong. But when they're right, it will tell you. And you get, I think, you get 5 shots. So if you know that they're all correct except that one, well, you make sure you remember what that one is, because we have to redo it again, right? So you have to fix it. And it even gives you a little clue. I'm not sure how useful that is, but at least it's a clue to what you need to do. And WebAssign has different kinds of results. You know, these are numbers. So we're going to be using today and tomorrow your calculator an awful lot. But later on, the answer might be 4x plus 7, right? It might be 17 elevenths. If you click on a box, WebAssign will give you a little palette that allows you to use mathematical symbols and so on. So if your answer does need to be the square of x plus 1, it will allow you to do that. That's pretty much it. So it doesn't matter if you get it wrong, as long as you eventually get it right. So you get like 5 shots, and that's normally, I used to do 3, but one of my students said that it helps if he gets a couple more shots. So yeah. You're going to get it right eventually, I hope. So 3 or 5 makes no difference to me. What else do we have on this guy? I don't know if, I think I can hit home. I'm in student view, so it's dangerous. There's your textbook. Right, so it's an ebook. Now this is dangerous. Here goes, click. You're never quite sure what it's going to do. Like nothing at all. Oh, here we go. Right. So if you, well, you could do that. I'm just going to jump into chapter 2. And the tangent line problem. And it's kind of cool because basically it, it takes you through a lot of steps, gives you some information, just like you would be reading your textbook. Then you go to the next page, then you go to the next page, right, and so on. So you don't need to buy a textbook. WebAssign has it as, part of what they give you. How good are we? Am I finished? Is there any questions about the class, the general questions that you'd like me to answer?
Sure, I have one.
Sure, go for it. What you got?
I didn't hear, did you say that the tests are open book, so you can use your textbook or not?
Oh, let's tell you, that's a good question. Tests and the final exam, you can use anything that's physically written down. So if you've written notes and formulas and aide memoirs and anything else you want to call it, if it's physically written down, you can use it. You cannot use WebAssign because you can't just go back and say, oh, I know you've done a question just like that. I'll go and look at what I did in question 5 and just do it that way. That's just too much help. But what will happen is on the day of the test, all of WebAssign will basically disappear. So you won't have anything to look at. So you can look at the ebook. Okay, that's not physically written down, but it's a PDF. It's equivalent to it. So anything that you've physically written down on your own, or the textbook. If you try to use the textbook to answer every question, you run out of time. So I would definitely make sure that you know what you're doing. That's going to be true in the final as well, that you can look up things up to a point. But time will kill you if you have to do it with every question. So that's how that's going to work. Good question. Anything else? And I'm going to be, I'm not sure what I'm going to be doing here. I'm going to be closing this and we'll get started shortly. Can I get out of student view? That would be nice. Well, let's do the fun stuff now. I'm now going to try my next piece of... okay, where are you? Yay! You should be looking at what I'm looking at, which is essentially some line paper on my camera. Okay. So, check. I've done the introduction to the course. So now let's look at the beginning of calculus. It's a simple problem, but it had mathematicians really, for want of a better word, bugged. What the problem was is that you take a function, y equals f of x. Now it could be anything. It could be x squared plus 1, could be sine x, it could be any function in the world. And at one particular point, that point there, which I'm going to call P, you want to find the slope of its tangent line, which is essentially the slope of that red line. So that's called a tangent line. Now you might think, what's the biggie? Well, it's a bigger problem than it seems. How do you find the exact value of that tangent line? That's the problem. Now you could say, well, I'll just draw the curve. I'll get a ruler and I'll draw a tangent line. And then I'll do my, can you imagine that's my tangent line? I'll do my little start somewhere like there. And won't I drop two down lines like this? And this is called the rise. And this is called the run. And I know how to get the slopes of lines. I just take whatever the rise is, right? And I divide it by the run. And hey, I've solved your problem. Well, that's an engineer's solution to that problem. That number that I would have got with my particular tangent line is not the same one that Jackson would have done. If I gave you a photocopy of this and sent it to everybody in this class, and I put a little dot at where P was, and I said, draw a tangent line, would you agree that we aren't all going to draw the same one? Aren't some of you going to do it a little bit steeper, a little bit shallower? Who's right? There's no way of saying my tangent line was better than your tangent line. Agreed? Now, secondly, let's say I somehow got this guy. Won't I need to know what these points are to get the rise and the run? But won't I have to round off the coordinates at that point? Because the chances are it's not going to be 5,7. Isn't it going to be 4.91233? Keep talking for a couple of days, comma 18.421, keep talking for a couple of days, right? You're going to have to round off. But if you round something off, isn't it no longer an exact answer? Isn't it an approximate answer? And remember what the problem was. We don't want the approximate answer to the slope of this tangent line. We want to know the exact answer. You see, it becomes a big problem. And so mathematicians had to figure out how to solve this problem. And when it finally got solved, calculus got invented. Right, the whole process of finding the solution to this problem created a whole branch of mathematics called calculus. It's amazing how some of the simplest things can generate some of the most useful pieces of math. So let's see how we're going to tackle this tangent line problem. Well, we're going to start from an engineer's perspective. Nothing wrong with that. It's a good way to start. I need a function, right? I really need to give this guy a name, right? So I'm not going to make my life difficult. Let's do it to x squared, right? Now, it won't take me too long to draw a sketch of x squared. So, and did that pen, didn't last long. Yeah, if you're going into teaching, always have a backup. So, oops. Are you all happy about that's what x squared looks like? Where would you get that from? I don't know. You probably knew how to do that way back in Math 99, right? If I said sketch x squared, if you really wanted to do a good sketch, couldn't I just go to that program called Desmos and say y equals x squared, and I could look at it if I wanted to see what it looked like? Now, let's pick a point. I'm going to pick this point here. And can we pretend that this point here, we'll call it P, has coordinates 3, 9. Are you happy about if the x is 3, the y coordinate is 3 squared? So that's where the 9 came from. And I want to find a tangent line. But we're only going to do an approximate one, right? So let's find an estimate. Now, I'm not going to get a ruler, draw a line. What I'm going to do instead is pick another point on the curve that's pretty close. So I'm going to pick this point here and I'm going to call it Q. And I'm going to make its x coordinate is 4 and its y coordinate is 16. So I'm going to estimate the tangent line. By using the line PQ. Now, would you agree that the line joining P to Q isn't a perfect version of the tangent line? I'm running out of colors here. Can you pretend for a minute that that dotted one was the perfect answer? But would you also agree it's close, right? It's an estimate. That's what it's meant to be. Now, if I want to find the estimate using the line joining P to Q, don't I need to find the slope of that line? So far, so good. Now, we know how to get slopes of lines. The generic version, which isn't the one I'm going to use, but it's the one I'm going to start with, is the rise over the run. You agree? Now, if I do a blown up version of what that guy looks like, I'll show you how we're going to work this. Can you imagine this is P at 3, 9, and the curve kind of goes like this, and this is Q at 4, 16, and this is the line PEQ. If you drop a little guy that way, and you drop a little guy going this way, and you make this a right angle, this is the thing that's called the rise. And this guy, this distance here is called the run. We're all quite comfortable with that. What was that? Is that Math 94, rise over run? Somewhere? Hey, is it? Hopefully it's part of your math that you don't even care where it came from, but you know it, right? So you see what I'm getting at? Little things that you thought, I'm not going to use rise over run again, it's done. It's not done, it's here. Now, I'm going to give you some notation that's very common. Instead of having to write down slope of line PQ, we're going to call it MPQ. And it's going to be equal to, oh, I should put in my function here. I know this curve is called y equals x squared, but in general, wouldn't it just be y equals f of x? In general. This guy here and this guy here. Isn't this guy the value of the function at 4? And isn't this guy the value of the function at 3? So what we're calling the rise is really the difference between the value of the function at 4 and the value of the function at 3. And isn't the run basically the distance from here to here? And isn't this guy 4 and isn't this guy 3? So the guy we're calling the run is 4 take away 3. Are we okay so far, so good? So in this case, it's going to be f of 4 take away the value of the function at 3 divided by 4 take away 3. Now the value of the function is 16 and this value is 9 and this is 1. So what do I get? I get 7. Now, what I'm going to do now is I'm going to try and generalize this process. So it's not just for x squared, it's for any function, y equals f of x. And this point P is going to be called x of P, comma, y of P. And this fella here is going to be called x of Q, y of Q. And that means that the formula for the slope joining P to Q is now going to be the value of the function x of Q to take away the value of the function at x of P over x of Q take away x of P, or you could call it y of Q take away y of P over x of Q take away x of P. Are you happy with the notation, what it means, essentially? Okay. So right now, I have got my first estimate for the slope of the tangent line at P, right? I would like a more accurate estimate. So we're back to y equals x squared again. I'd like a more accurate estimate for the slope of the tangent line at this point P. What could I do to make that happen? Give you a clue. Can I change who I pick Q to be? Could I make Q another place?
Yeah, the origin.
Oh yeah, I could put it down there. Since I want the tangent line at this point here, right, like that pen, I could put it at the origin. Would it make more sense if I brought it closer to P? Would you agree it'd probably be closer to being a good estimate? Right. So if you want a more accurate estimate for the slope of the tangent line at P, pick a Q that's closer. Okay, so I'll start off with a little table. Here is the coordinates of P. They are not going to move. Right? Q was 416, and the slope of the tangent line, the estimate, can go here. And the estimate that I got was 7. Okay, so I'm going to keep that guy as 39. And how about 3.1? Would you agree that the line joining P at 39 to 3.1, I'm about to find out what 3.1 squared is because I'm not risking doing that in my head, 9.61. Would you agree that that would be a closer estimate, right? A better estimate to the tangent line? Would that seem reasonable? Now, what would that look like? Well, if I was doing it over here, it would be the value of the function at 3.1, take away the value of the function at 3, and 3.1 take away 3, and the value of 3.1 is what? 9.61, take away 9, divided by 0.1, and the answer I got would be 6.1. So our first estimate was that the slope of the tangent line would be 7. Our next estimate is that it would be 6.1. If I wanted an even better estimate than the one that I just did, what X coordinate do you think I should pick for Q?
3.01.
Yeah. And again, I'm not going to even attempt to do that in my head. And the answer I get this time is 9.0601. Can you just trust me because we're running short of time here? But the answer ends up being 6.01. And then I said, to heck with it. Let's go for glory. Let's pick Q at that coordinate. And if you did that, and you can double check my working later, the Y coordinate ends up being, and again, you're going to have to check my working. And then you make the leap. And it is technically a guess. So my best guess for the exact value of the slope of the tangent line at the point P is, math is full of patterns, right? We see patterns everywhere in the universe, in science, and we certainly go looking for them in math. Based on what you can see here, do you see a trend or a pattern? If you were a gambling person and you could only pick one number to be the slope of the tangent line, what would you pick?
Looks to be getting closer to 6.
I think most of us would agree. Now, That is an engineer's solution to the tangent line problem. And you will get homework questions that essentially do exactly the same thing. And tomorrow I'll show you how you can do some of these calculations, right, this thing here, using the TI-84. And just, you know, x squared wasn't that bad, but can you imagine the function was x squared plus 1 over 2x minus 3? That would not be a pretty calculation if you had to do it 12 times, right? So we'll show you a quicker way of doing it. But that is an engineer's solution. And by the way, that is the correct answer. It is the exact value. And so some of you might be saying, oh, well, I know a big deal. We'll just do it this way. The problem with this is that there is no guarantee that this is the exact answer. Would you agree that couldn't there be a situation where the exact answer was 6.0014? Would you be able to tell? Not really doing this method. You know, no matter what two numbers you pick, right? No matter how close you make Q to P, isn't there always a possibility that the answer might be slightly different from whatever calculation you've got? Theoretically, at least, that can happen. So to give you a little, I know we're overshooting a little time, but just to make your brain hurt, someone went and said, I'm sure they did, why don't we just make P and Q the same point? That should solve the problem. Well, let's show you the problem if you make P and Q the same point. Great.
Zero and dividing by 0.
And that is not a good place to be. And no, the answer isn't 1. Just in case you were thinking. The solution to how to deal with that is the essence of where the beginning of calculus started. They tried to figure a workaround for making P and Q the same. You can't make them the same, but what you can do instead is, imagine my fingers are P and Q, is can't you bring them so close to each other that they're no longer able to tell the difference in any practical way? And that process is called limits. And we use this process called limits to do the equivalent of making P and Q the same. They're not going to be the same, but they're going to be so darn close it won't matter. And that will give us our answer. Right, and in case you forgot,